Hello and welcome to this video, and this is going to show you how to find unknowns in the trig equation where there's a coefficient of x either than 1 or 0, and also how to find unknowns in a quadratic, in a disguised quadratic where there are trig functions and not just your normal x squared or x. Let's start by saying, say, sine 2x equal to minus 0.39. Now, I'm looking for the answers in the range of 0, x, 360. Now, the coefficient of x can make this look a bit scary because you think you cannot divide by 2, because dividing by 2 won't get rid of that coefficient of x. It would just make that minus 0.39 over 2 and make that sin 2x over 2. So you just have to get rid of the sign by sine inversing minus 0.39. So then you're just left with 2x. Now you think, now I can get rid of the 2. No, by getting rid of the 2 now, you actually lose answers to your question. You'll actually end up with less answers than you should, and that's lost marks. So what you try and do is keep the 2x for as long as possible before you start dividing and getting rid of it. What I mean by that is, say 2x is equal to minus 22.95. That means 2x is equal to, using on my last video, we say 180 minus your answer, and then you'll get 202.95 degrees. It's in the region. 2x is also equal to minus 22.95 plus 360 plus 360. This equals 337.05. Also in the region. And these are your two answers. And you can add or subtract 360. So let's add 360 to the second one. That's 202.95. 2x is also equal to 562. Can't read. 0.95. Let's take this 337.05. Let's add 360 degrees to that. I mean that's also an answer. We like answers. But wait, these last two don't appear to be in a region. But you've got 2x, so now you have to divide the tick for this one. Divide all these answers by 2. Divide all these that are in the region by 2. Then you'll be left with 202. You have 202.95 divided by 2. You get x equals 101.475. You get 337.05. X on its own is just equal to 168.525. 562.95. X is also equal to 281.4 697.75. And lastly, 697.05. X is also equal to, if I could draw a better X than that, X is also equal to 348.525. You basically, when you've got a coefficient of X, you need to keep that coefficient of X for as long as possible and find as many answers in the region that you can before then dividing by 2. Because if you simply divide by 2 now, then you'll get 11.475 minus 11.475. You'll miss some of the outer answers towards the end of the region. So that's why you've got to keep the coefficient of X, find as many answers as you can, and then just divide them by 2 and then see if they're in the region, and if they are, take them. Now, as I said, a little treat. A question from a Solomon OCR paper. Solomon obviously meant to be harder than the real thing, but we like that. And well, this is find the values of X in the interval 0 to X to 360, for which 5 sin squared X plus sin X minus cos squared X equals 0. Right, this does look a bit brutal, only due to the fact that, well, we've got this cos squared X and we've got sin squared X and sin X everywhere, so let's try attempting to get it in terms of sine. Now obviously, going back, sine squared X plus cos squared X equals 1. So cos squared X is equal to 1 minus sine squared X is equal to 0. Now, get rid of the bracket, you'll get minus sine squared X is equal to plus sine squared X. So that will add on and you'll get 6 sine squared X plus sine X minus 1 is equal to 0. Alright, what now? Disguise quadratic. I always say to the examiner, let sine X equal t. You've got 6t squared plus t minus 1 equal to 0. Better. Where sine squared X equals t squared. Okay. Now, where now? So, basically, it's just like solving a quadratic. And this 1, they're both got a coefficient of 1. Well, that one minus 1 strictly speaking, but that sort of indicates to me that that's a combination of a 3 and a 2 t. Now, got a positive t, so you've got 1 and minus 1, because that's what makes the minus 1. 1 plus 1 times minus 1. Where does the plus 1 and minus 1 go? Plus 1 here, so you have plus 3t minus 2t. Sorry, I haven't done this before, so I am a bit slow. I'm just doing this example off memory. Right. That means then you've got your answers. You've got t equal to a third, or t is equal to minus a half. Let's go back to this sin x equals t. So that means sin x is equal to a third, and sin x equal to minus a half. So from here on it's just a basic plug the numbers in, and then you just use your little plus minus 180 minus your x, and then plus or minus 360 into that. So you've got if x equals sin x equals a third, you've got x equals 19.5, 3 decimal places, and then sin x equals minus a half, got minus 30 of course. Minus 30 isn't in the region, but what is x equals 180 minus 30 equals 210. This basically shows that you don't just type it into a graphical calculator and then just write down your answers on the page. You know how sine curves and cosine curves work, don't we? So let's carry on. You can also get x is equal to minus 30 plus 360 is equal to 330, and using this 19.5 plus or minus 360 to that will be out of the range, so it's just simply x equals 180 minus your answer equals 160.5. So just to make that clear, we've got x equals 19.5 equals 160.5, then we've got x equals 210 and x equals 330, and that's it. You'll only ever be asked to use these two trig identities to rearrange equations, and then they like to put a disguised quadratic in there. So then this would represent a graph. So then the disguised quadratic just makes it easier to get your answers rather than having the sign there all the time. And then you just change it back using what you've written here. T equals sin x, so sin x equals third, that's t equals a third. And then it's just a simple sine inverse it, plus 180 minus answer, plus minus 360. And it would be the same if it was in terms of cos. You just have cos x equals a third, and then you'd have plus or minus the answer, plus or minus 360. You just apply the rules to what you're given. I mean, they'll only ever give you, over these sorts of questions, these will be more end of paper, or simple sin x equals this, or sin x equals tan x, find in terms of one trigonometric function. That's all. This is all for trigonometric functions, although I'll be posting a video about how to find these little instead of using 180 minus answer to find your new answers, how to use a little graphical method to find these, which I find a little easier. Stay tuned.